Water is a very important molecule in terms of our studies of acids and bases. When a water molecule splits into ions, it forms H+. It donates a proton to solution. It also forms OH- hydroxide ion, which will accept protons from solution. So water is a substance that's termed amphoteric. It will act as both an acid and a base. The equilibrium constant for water is what helps define the pH scale. If we determine the equilibrium expression for water, we take the products over reactants. So this will be the concentration of H plus times the concentration of OH minus. Since our reactant is a liquid, it is not included in the equilibrium expression. So this equilibrium expression is so valuable that it's given its own variable. It's called the Kw. And at 25 degrees Celsius, Kw equals 1 times 10 to the negative 14th. Since we know the equilibrium constant at that temperature, we could determine H plus and OH minus concentration. Since we have a nice ratio of H plus to OH minus of 1 to 1, at equilibrium we could define both of those concentrations to be X. So if we solve for X, we would get the square root of 1 times 10 to the negative 14th, which is 1 times 10 to the negative 7th. So at 25 degrees Celsius, the concentration of both H plus and OH minus is 1 times 10 to the negative 7th. If we look on our pH scale for H plus ion concentration, that corresponds to the neutral pH. So water is unique because it shows that when we have an equal concentration of H plus ion and OH minus ion, we're going to end up getting a neutral pH. Take a second to understand the magnitude of the equilibrium constant for water. It is 1 times 10 to the negative 14th. It's a very small K value. Remember, a very small K value means reactants are favored. So water does not split up into ions hardly at all. In fact, for every 500 million water molecules, only one of those water molecules would split into ions. That results in a very small K value. Now let's use this equilibrium constant to solve a few problems. If you know the H plus concentration or the OH minus concentration of a solution, you can easily determine the other concentration of the ion. For example, if tap water has an H plus concentration of 3 times 10 to the negative 7th, what is the concentration of OH minus? We can use our equilibrium expression to determine this, since we know H plus times OH minus is 1 times 10 to the negative 14th. All we got to do is plug in our H plus concentration and solve for the OH minus concentration. When we do that, we get 3.3 times 10 to the negative 8th molar for our OH minus concentration. Pretty simple equation to use, so I want you to try one here. Pause the video and solve this next problem. Determine what the H plus concentration in a sample of seawater is if the OH minus concentration is 2 times 10 to the negative 6th. Remember, the H plus OH minus concentration equals the Kw, which is 1 times 10 to the negative 14th. When you think you got your answer, press play and see how you did. You should have gotten an answer of 5.0 times 10 to the negative 9th for your H plus concentration. Let's look at a few quickies involving this equilibrium expression. We know that H plus times OH minus has to give us 1 times 10 to the negative 14th. So if one of the ion concentrations is given as 1 times 10 to the negative something, we can figure out the other concentration very easily because we know the product of the exponents has to give us 14. And when we multiply exponents together, we just add them to determine what the overall exponent would be. So, for example, if we know the OH minus is 1 times 10 to the negative 12th, well, we know H plus then has to be 1 times 10 to the negative 2nd, because negative 2nd plus negative 12 would get us the negative 14. So if the H plus concentration is 1 times 10 to the negative 5th, Well, to get to 1 times 10 to the negative 14th, the OH minus concentration must be 1 times 10 to the negative 9th. All right, for household ammonia, if it's 1 times 10 to the negative 3rd in OH minus concentration, then you know the H plus concentration would have to be 1 times 10 to the negative 11th, because negative 11 plus negative 3 gives you negative 14. These quickies can only be done if it's 1 times 10 to the negative something. If it's not 1 times 10 to the negative something, it won't be as quick. You'll have to calculate it as we've done before. Now, let's determine whether these solutions are acidic, basic, or neithers. All we have to do is look at the H plus concentration and our pH diagram. We know anything with an H plus concentration of 1 to 1 times 10 to the negative 6th is going to be acidic, whereas 1 times 10 to the negative 8th to 1 times 10 to the negative 14th is going to be basic. So we just have to find those concentrations of H plus on the table, and we can determine whether it's an acid or a base. 10 to the negative 2nd is on the acid side. So gastric juice is an acid. Black coffee, 1 times 10 to the negative 5th, is also on the acid side. Coffee is acidic. Household ammonia is 10 to the negative 11th. That falls on the basic side. Ammonia is a base.